Hello, in this video I'm going to talk to you about how to solve a system using substitution. So if we look at our steps here for substitution, it says step 1, we want to isolate one of the variables. So what we mean by that is we want to solve one of the equations for a single variable. Then we're going to substitute that back into the other equation, and then we should be able to solve for one of the variables. To kind of explain these steps a little bit more, let's look at it. Just to remind you kind of what we've already done with this, we know that a system means that there are two or more equations that have the same solution. So when we talk about systems, the first way that we talked about graphing a system is one way that you can solve it. So if you have a system and you graph that system, the place where those two lines meet is your solution. We also know that there's sometimes when the two lines don't meet. Perhaps you have two lines that are parallel. If this happens, we know that there is no solution. And the third thing that can happen with a graph is you might have two lines that are actually the same line, but the equation is just written a little bit differently, and in which case we would have infinite solutions. So these types of answers for a system exist no matter what method you use. They're just easiest to see while graphing. So then the second way we learned how to solve a system was elimination. And we know in elimination that you try and eliminate either the x or the y variable. The third way to solve a system is by substitution. And that's going to be the method that we look at today. Example. All right, so here we have our first example. We have two equations, y equals 2x minus 1 and 3x plus 2y is 26. In this case, when we look at our step 1 to isolate the variable, we already have that. One of them is already solved. So we can see here that one of our equations is already solved for y, and that y is equal to 2x minus 1. So once I have one of the equations solved for a variable, or once I have isolated one of the variables, I'm actually going to substitute that expression in. So I know that this is equal to y. Well, y shows up in the second equation right here. So I'm going to take this 2x minus 1 and plug it in here for y. So that's what they've done. We have a 3x plus 2y is 26. In place of y, we have put this 2x minus 1, and then we're going to distribute. So if we distribute 2x times 2, we get a 4x. 2x times negative 1 is 2x. That's how they came up with this. Our next step would be to look for like terms to solve our equation. So we can see here that we have like terms with 4x and 3x. That gives us 7x. We keep the negative 2. And now we can draw our line and solve our equation. We add 2 to each side, divide by 7, and we have an answer of x is 4. Now, we know that once we figure out x is 4 that we are halfway done, because a solution to a system is always an ordered pair, so it's two numbers. So the next thing I'm going to do is I'm going to take that 4 and I'm going to plug it into one of the equations. The best thing you can do here is plug it in for the equation that had an isolated variable. So what I mean by that is if I have an equation that's already solved for the other variable, like I do here, I'm going to plug that x into that equation. And that's what they've done here. So they've taken this y equals 2x minus 1, and we've plugged in the x right here. So we plug in our 4. 2 times 4 is 8. 8 minus 1 is 7. That's how they get their ordered pair of 4, 7. All right, so let's try this whole thing again without the steps in front of us. All right, so if we are looking at this equation here, move it to the top so you can see it. We have a system, y equals 2x plus 5, and 3x plus y equals 10. Now, step 1 is always to isolate for one of the variables. So we're going to try and isolate one of the variables here. If we take a look, it actually looks like one of our variables is already isolated, and that variable is y. So I can see y here is already isolated and it's already by itself. But what is y equal to? Well, y is equal to 2x plus 5. So I'm going to take that 2x plus 5 and I'm going to plug it in to my second equation in place of y. So that's going to give me a 3x plus, and instead of putting in this y, I'm going to put in this 2x plus 5, and it's all still equal to 10. So again, all I've done is I still have my 3x from right here. I still have my 10 from here, and in place of this y, I put in what I had my first equation solved as. All right, now I'm going to put together my like terms so I can solve. I don't have to distribute because there's nothing actually outside of the parentheses, so I'm just going to put together these two like terms. It's going to give me a 5x plus 5 equals 10, and now I'm able to solve this. I would subtract 5 on each side to give me a 5x is equal to 5, divide each side by 5, so x is 1. Now I know that I'm halfway done with my equation because I need to find out what y is equal to. So my last step here is I'm going to take this solution that I just found, where x is 1, and I'm going to plug it back into one of the equations. Again, I would suggest you plug this in to the one in which you already isolated the other variable because it will be easiest to solve. So that equation is y equals 2x plus 5. I'm going to put a 1 right here in place of this x. So I'll have y equals 2 times 1 plus 5. 2 times 1 is 2. 2 plus 5 is 7. So my solution is 1, 7. And remember, guys, if you're concerned, like you're not sure that you did this right, you can always graph these equations. You could put them right into Desmos if you would like, and you can see where the lines cross, and that should be your solution. All right, so let's try this now with another example. And you can see in this one, we don't have one of the variables already isolated. So our first job is to decide which variable we want to isolate. So when deciding which variable to isolate, look for the variable that has a coefficient of 1 or that does not have a coefficient in front of it. So if I look at what I have here, the one with a coefficient of 1 or does not have a coefficient is this y right here. So in order to isolate this variable y that we've just found, I'm just going to solve the equation for y. So just like I'm trying to put it in slope-intercept form, and you can do this for x or y, this one just happens to be y, I'm going to get y equals a negative 3x plus 7. Remember, these are not like terms, so I cannot put them together. So now that I've done that, I now know that this is what y is equal to. So I'm going to take this and I'm going to plug it into the other equation for y. So that will give me a negative 2x plus 4 times negative 3x plus 7 equals 0. So all I've done is taken what I solved to be y and plugged it in place of y. And now I'm going to distribute and solve my equation. That'll give me a negative 2x plus, minus 12x, because 4 times negative 3 is a negative 12, plus 28 equals 0. Again, we're going to look for our like terms, which we can find right here. So that would give me a negative 14x plus 28 is 0. I need to get the variable on the side by itself, so I'm going to subtract 28 on each side. It would give me a negative 14x is negative 28. And finally divide by negative 14. And I can see x is equal to 2. So again, I'm now about halfway there. And I'm going to have to plug this back in to see what is going to happen. So to find the other answer, I can plug this 2 back into what I solved y to be. So I'm going to take this equation from over here, this y equals a negative 3x plus 7, and I'm going to be plugging in a 2 for x plus 7. Negative 3 times 2 is negative 6. Negative 6 plus 7 is 1. So my solution is 2, 1. And again, you can always check these. All right, we have one more example that we are going to try. Excuse me. Let's move it up top. All right, so we want to do the same thing. Step 1, decide which variable to isolate. So look for the one that has a coefficient of 1, or it may appear to not have a coefficient. And hopefully what you're seeing is the one that we could choose would be this x right here, because it has a coefficient of 1, or you can see it doesn't really look like it has a coefficient. So the first thing I'm going to do is take this equation, I'm going to write it over here, I'm going to solve it for x. So this time I'm solving for x, not y, and that's okay. Again, these things over here are not like terms, so I can't put them together. So I have a negative 2y plus 1. So now that I know what x is equal to, I'm going to take this and I'm going to put it into my other equation for x. So that will give me a 20 times, in parentheses, negative y plus 1 minus 30y equals negative 50. So you can almost see how this is similar to elimination in that you're trying to solve for a variable so that you only have one variable in your equation, because we can't really solve an equation if there's two variables in it. All right, so we're going to distribute our 20. That would give us a negative 40y plus 20 minus 30y equals negative 50. Let's look for our like terms. I have negative 40y and negative 30y. So let's put those together. Give me a negative 70y plus 20 is negative 50. Subtract to try and get that y by itself. It'll give me a negative 70y is negative 70. And I can divide by negative 70. And I see that y is 1. Again, I'm about halfway there. Finally, I'm going to take this answer I just found for y, and I'm going to put it back into this equation so I'm able to solve for x. So I will have x equals negative 2y plus 1, and in place of that y, I'm going to put a 1. That would give me a negative 2 plus 1, which is negative 1. So my solution here should be negative 1, 1. So as you can see, this method is just a little bit different. You usually want to use this method when you have equations that are set up similar to what we have here, where you have one variable that either has a 1 for a coefficient or has no coefficient, and they're both probably in standard form. So that's usually a giveaway. Kind of like what we did in the other ones, you could also have it where it's already solved for one variable. So I hope this was helpful to you, and now you can go and try some of the practice problems that should be linked below.